Hello, this is David Wales for my final submission for Game 377. Um, so first I'll kind of start this off with what I did this past week, um, and the week before, kind of, but mainly for this week. Was I did a lot of the ray tracing that we had gone over. So I'll I'll show you how I did it first before I actually show you in game. Um, so basically, I put it in my tools class. I originally this kind of ties into my personal project, the physics part. I had originally planned to put it in the physics, but then I had decided after thinking about it, I was wondering like why I should actually limit it to just physics things. Anything should really be able to raycast. So I just put it in the tools, and that way it can be called from anywhere. Um, so I implemented a bunch of different types of raycasting, kind of, or a bunch of different. They do a bunch of different things. So like this one, you just give it the segment, and it returns a list of the collidables that it intersects with. Um, I have this one, which you give it a collidable, and it checks if it's colliding with that, returns true if it is, false if not. I implemented raycast all, which just goes through all of the collidable groups, and it just returns all collidables that that ray is colliding with. So this one's without a doubt the most expensive, but if it's needed, it's here. And like I said previously, these other ones are here to lessen the load and less need for this one. Also, this one's templated. That's how you give it. So you give it like in my tank bottom here. I gave. I think I did this one somewhere. My tools ray class. Oh, I did here. So yeah, you just pass it in as a template argument, and then it will just return all of the ships that were hit in this case. Then I have the ray terrain intersection, which just calculates if the ray is hitting the terrain, essentially. And then I did the screen to world point. These were all kind of part of my physics thing, so there's that. I'll show you, I think this first one I'll show you is the terrain intersection and my raycast all. So if I run it, builds, I fall down, that's the gravity portion of my thing. I'm lagging a little bit. I think it's because I'm recording. So, as you can see, one of the things I did not implement this week, or that I had tried doing it, but I couldn't figure it out, was the line itself and the smart figuring out which AABBs to test it against on the terrain, essentially. So I just used basically the same thing as the what it does for collidables. So it just gets min point, max point, and then gets all of them. So it's something, but honestly, it's not the best. But the actual collision with the terrain does work. Um, but I'll show you with these first. Uh, I think I have it set up right now to actually push these away when my ray hits it, and this is raycast all, so it just hits them all. So as you can see, it's also staggered, and there is a group AABB that it checks with as well. But yeah, right now you can see the sphere, you can see the bounding, or you can see the OBB in this. I go in a little bit and it gets rid of the sphere because it's colliding with it. And then if I go forward, it'll start pushing it because I'm actually colliding with it. I'm colliding with those objects, rather. Okay. So then you can see those lines that were appearing. Those were my collision with the terrain. I have it set up so it's showing the normals of the triangles. So when I go in, you see there, it goes in, it's colliding with that, so it gets the two triangles, and it creates the normal there. Obviously, that wouldn't be there in an actual release, but um, I'll zoom in and show you that it actually works. Let's go right above the endpoint. So you can see collision there. It didn't collide until until then it's hard to show on these. And then it's finally colliding because it's inside. And then when I go past, I'm no longer colliding with it. See, they're all just blue now. So yeah, there's that. I'll get rid of this one. I'll get rid of this as well. Show you this the normal raycast. So this one I actually have it's actually drawing the group aabb show. So pause it there. Okay. So group aabb not hit, and then right there it's hit. And then let's get a better view for the sphere. Okay. So group aabb hit, and then right there I'm colliding with the actual thing because I was going too fast. But I'm colliding with it, and then as soon as I leave it, then it's no longer red. My array is no longer red. And then as I go in and out, the different levels show and don't show. Okay. So then that's it, I guess, for the showing portion, essentially. Or, well, actually, I'll show you the mouse, the screen to world point. I just did the same thing that you did in class, basically. So I'm creating a cube, and it's just being drawn on the near. So right there, you can see it, and it moves wherever my mouse is moving. And if I zoom out, and it still follows my mouse, it's still calculating the world correctly. So yeah, there's that. Okay, and then I can now to the actual code portion, I guess. So I believe I implemented everything that was required for this entire quarter. So what I can remember, or what I have listed, I have I separated the collision volumes into a little hierarchy. So just what we had done before with the collision volumes, box colliders, and then under box colliders, ABB and B sphere, and then or under box colliders, ABB, ABB, and OBB, not B sphere. B sphere is just underneath collision volume. I did my revised collision system to no longer use the function pointer. I obviously implemented ABBs, OBBs. I obviously also did the cross collision between collision volumes. I did, from my recollection, I did layered collision processing for everything. So even the rays, I have it. But I also have it for all the individual collision volumes. Um, I did a visualizer. I have down here tools. I basically this is just composed. This is almost identical to what you have, I believe, but basically it just has the line, sphere, box, and marker, so I can show all of those. Um, and those were, I guess, kind of the mandatory things I could think of. And I guess on the optional side, some of the things I had discovered when I was implementing things was I really needed the mouse input. So that's what kind of led me to implement mouse input into this. Um, Actually, if I run it, one of the ways I was testing my mouse was I can create a fleet with my tank by just right clicking fleet of ships. And it just creates all these ships where I am. So yeah, mouse works if I right click, it works there. But yeah, I realized I really needed that. That's also how you shoot bullets in my thing. So you can see in here, I just or actually, it's the registering is actually done in my tank top, I believe. Yeah, mouse pressed, button left, and then here is creating a bullet. Um, and then I also really realized I needed something to control the camera. So this kind of ties in. This wasn't an actual personal project, I guess, but like it almost was to me because my physics stuff was almost like the way I had it set up here was it was very much similar to what we had, but like the way the functions I guess are set up with these pure virtual. I have some pure virtual functions I believe in here. Oh, this is game object that explains it. Clicked on this. Okay. So yeah, my pure virtual functions I have in here, which then I use to they're automatically implemented in game object. So then I can also just use those to update the physics variables. And I did a very similar thing in my attachable. So you can see are also pure virtual functions. So while they are separate and technically the physical is my personal project, both of them were like very much like interrelated, I guess. Um, So yeah, basically it keeps like the general layout of what we had done. So like the UBL class and then a manager for the UBL. Then you register, deregister, it's in the scene. All of the normal things. Those pure virtual functions are really what made both of them. As far as the attachable is concerned, it also same thing. So the pure virtuals register, deregister, manager, UBL, game objects derived from it. The only difference with this is that I had an attachable strategy, which would allow me to mimic attached or orbit attached. Mimic attached would just rotate along with the object it's attached with. So, like the tank top rotated at the same rate as the tank bottom. So it was just a mimic attached. Versus the camera, which needed to rotate around the object it was attached to. So that was orbit attached. And I just set those in the level. So I attached tbot, I attached top to tbot, and then I attached cam to tbot, and mimic and orbit. And that's what the difference was between them, essentially. But it really helped out. I really needed that. And then I guess as far as an organizational aspect, one of the things I had changed was my resource managers. After putting in the terrain asset, my resource manager, I had everything in just the one class, and it was getting way big and just kind of very like clustered. So I ended up separating it into individual managers that would just essentially go through the resource manager. So resource manager has like the master functions essentially. Um, and then it would just call the individual functions and their actual functions. So there's that. Trying to look at what I've missed. So yeah, as far as extra work is concerned, I did the attachable. I did the two different versions of attachable, or two different strategies for attachable rather. Um, and I did the ray tracer or ray tracing for the physics, my physics portion, but it's actually in the tools. Um, I did the physicable, which admittedly is essentially just pseudophysics. Most of my research into that was just my own notes from previous courses and stuff, and I I wish I could go back to it now, actually, even though we aren't even technically done with the class. But I kind of wish I had started, I guess, programming it earlier because right now the way it's set up is essentially like it's pseudophysics. Like none of it is a lot of it's like fake physics equations and stuff even. So so like the force is like it just takes the velocity and like it's not keeping mass as like a variable. Like it's just kind of faking it essentially. But I think it works for the purposes of what I wanted to do. It does the class does give the user a a different way to control the character and gives them more control over it, which is what I was really going for, I guess, with this. This basically has force and gravity, um, and that's basically it as far as like the actual movement is.